Students, today I will start our third unit, that is mean value theorems and Taylor series. Mean value theorems and Taylor series. Okay, first we will learn about Rolle's theorem. Rolle's theorem. Rolle's theorem. Okay, first write down statement of this Rolle's theorem. Okay, write down statement: if a comma b are two real numbers a less than b and f is a function such that f is continuous on closed interval ab, f is differentiable open interval a comma b, f of a is equal to f of b, then there exists C belongs to open interval a comma b such that f dash c is equal to 0. That means in this video we will learn about Rolle theorem. So this is the application of continuity and differentiable. First, we will try to understand what is Rolle theorem. After that, we will learn how to verify Rolle theorem. So first, we will discuss about Rolle theorem. What is meant by Rolle theorem? There is a statement that is, let f from closed interval a comma b to real number be a function. Let f be a function from closed interval a comma b to real number. Here a and b are real numbers. Here A and B are real numbers with condition. What is the condition? A less than B. So here A and B are any two real numbers with the condition. What is the condition? A less than B. So here A must be less than B. Okay. Remember that point. So the theorem says f of x should be continuous or continuity. F of x should be continuous on closed interval a comma b. F of x should be continuous on closed interval a comma b. Next, second one, f of x should be differentiable on open interval a comma b. Third condition, which is f of a should be equal to f of b. F of a is nothing but the value of f of a is nothing but at x is equal to a, at x is equal to a, f of x is equal to f of a. Okay. F of b is nothing but at x is equal to b. F of x is nothing but f of b. Okay. So here f of a should be f equal to f of b. Okay. These three conditions are satisfied. So then there is at least one C. So here we can find more than also, no problem. Where f dash C going to be 0. Okay. If suppose the function f of x satisfies all these three conditions, then we can say that Rolle's theorem is applicable, otherwise does not applicable. That means if at least one condition, if at least f of x does not satisfy one condition or f of x does not satisfy any one of the condition, so then we can say that Rolle's theorem is not applicable. If the function f of x satisfies all these three conditions, so then we can say that Rolle's theorem is applicable, otherwise does not applicable. Okay. If at least any one of the condition f of x does not satisfy, then we can say that Rolle's theorem is not applicable. Okay. Okay. So here there is a graph. Okay. What is the graph? Let us consider xy plane, coordinate plane. Okay. Let us consider y is equal to f of x be a curve. Let us consider y is equal to f of x be a curve from closed interval a comma b to real number. Suppose this is a, this is b. Okay. So here a less than b. Okay. Tell me what is this length? Tell me. This is f of a. Okay. This is f of b. Okay. So here f of a is equal to f of b. Okay. Very, very important graph. Okay. You can observe here there are three conditions. What is the first condition? What is the first one? F of x continuity on closed interval a comma b. Okay. What is the second condition? F of x differentiable on open interval a comma b. Okay. So you can observe here, student, in this graph the curve y is equal to f of x is continuous. So here this curve always continuous. Okay. So the first condition is satisfied. Okay. And we can differentiate this graph everywhere. Okay, we can differentiate this graph everywhere. So second condition is also satisfied, and you can observe here f of a is equal to f of b. F of a is equal to f of b. So third condition is also satisfied. So then there will be at least one c. Okay, then there will be at least one c where f dash c going to be 0. Whenever you are saying f dash c going to become 0. Here f dash c is equal to 0 means slope of the tangent is 0. Okay, once again I will explain, no problem. Okay, so if suppose the function satisfies all these three conditions, so then we can say that Rolle's theorem is applicable. So then in this case there will be at least one c, okay, which lies in open interval, where f dash c going to be 0. Okay, f dash c going to be 0. Okay, you can observe here. So this curve is continuous on closed interval a comma b, and we can differentiate this graph everywhere. Okay, and f of a is equal to f of b. Okay, so then in this case there will be at least one c which lies in open interval a comma b, where f dash c going to be 0. Whenever you are saying f dash c going to become 0, so here f dash c is equal to 0 means slope of the tangent is 0. So this is the slope of the tangent is 0. So this is tangent line. Okay, don't worry. So finally we can say that the existence of a point c which lies in the open interval a comma b such that f dash c is equal to 0 on the curve y is equal to f of x. Okay, which show that there exists at least one point where the tangent is parallel to x-axis, or in this graph slope become 0 at least one point which lies in the open interval a comma b. So this is the claim of Rolle's theorem. Once again I will explain. Okay, listen carefully student. Okay, so here Rolle's theorem says that if these three conditions are satisfied, then there exists at least one c which lies in open interval a comma b such that f dash c is equal to 0. You can observe here f of a is equal to f of b. F of a is equal to f of b. There exists c which lies in the open interval a comma b means there exists a point c in between a and b such that f dash c is equal to 0. You can observe here f of a is equal to f of b. There exists c which lies in open interval a comma b means there exists a point c between a and b such that f dash c is equal to 0. You can see here at the point c. Okay, so this is the point c. There exists a tangent to the curve which is parallel to x-axis. Okay, I will explain once again. Okay, Rolle's theorem says that if a function f of x satisfies all these three conditions, then there must be a number c such that a less than c less than b. Okay, then there must be a number c which lies in the open interval a comma b for which f dash c is equal to 0. Okay. Rolle's theorem states that if a function f of x satisfies all these three conditions, then there must be a number c which lies in open interval a comma b such that f dash c is equal to 0. Okay. Okay. So what is the first condition? Tell me. Okay, f of x continuous on closed interval a comma b. Second condition, f of x differentiable on open interval a comma b. Third condition, f of a is equal to f of v. Then there exists c which lies in the open interval a comma b such that f dash c is equal to 0. Okay. So this is the statement of Rolle's theorem. Okay. If suppose the function f of x satisfies all these three conditions, we can say that Rolle's theorem is applicable, otherwise Rolle's theorem does not applicable. So in this case we can find at least one c which lies in the open interval a comma b such that f dash c is equal to 0. Okay, remember that very important statement. Okay, with graph, statement with graph. Okay, now we are going to see verification of Rolle's theorem for the function. Okay, write down. Write down. Verify Rolle's theorem for the function. Very important, very easy. Okay, x square plus 2 in closed interval minus 2 comma 2. Okay, so we need to verify Rolle's theorem for this function. Now we will see how to verify Rolle's theorem. First we will check that Rolle's theorem is applicable to this function or not. How to check Rolle's theorem is applicable or not? How to check Rolle's theorem is applicable or not? First thing, we will check that it is continuity or not in closed interval minus 2 comma 2. Okay. Second thing, we will check that it is differentiable or not in the open interval minus 2 comma 2. Third thing, we will check that f of minus 2 is equal to f of 2 or not. Okay. You can observe here, student, the given function is polynomial function. This is a polynomial function. Already we know that all polynomials are continuous and differentiable functions. Already we know that all polynomial functions are continuous and differentiable. Okay. Similarly, all trigonometric functions are continuous, differentiable. Similarly, all exponential functions are continuous, differentiable everywhere. Okay. Next, logarithm function is also continuous and differentiable. Okay. So here f of x is, first one, f of x is continuous on closed interval minus 2 comma 2, because already we know that all polynomials are continuous. Okay, write down directly, no problem. Next, similarly, f of x is differentiable, DBLE means differentiable on open interval minus 2 comma 2. Already we know that all polynomials are differentiable. Okay, so these two conditions holds good. Now we need to check third condition. Now let us check. So first we have to find f of minus 2. Tell me f of minus 2. Okay, for finding f of minus 2, just you have to substitute x is equal to minus 2 in the given function. That's all. F of minus 2, tell me, minus 2 whole square plus 2 is nothing but minus 2 whole square, 4, 4 plus 2, 6. Similarly, we have to find f of 2. F of 2 is nothing but 2 square plus 2 is nothing but 6. Therefore, f of minus 2 is equal to f of 2. So, once we checked that first one, second, third condition holds good. So, once we checked first, second, third condition holds good. Now we need to find C values in open interval minus 2 comma 2 for which f dash C going to be 0. Okay, here if you are able to find at least one C which belongs to open interval minus 2 comma 2 where f dash C is equal to 0, then only Rolle's theorem is verified, otherwise not verified. Now let us see. Okay, first we have to find f dash of x. Tell me, f dash of x is nothing but derivative of the function f of x. Tell me, f dash of x, 2x. F dash of x is nothing but 2x. Okay, remember students, so here very important point. Okay, f dash of x is equal to 2x. Okay, here f dash of x exists. F dash of x exists for all x in the open interval minus 2 comma 2. That means f dash of x is defined for all x in the open interval minus 2 comma 2. That means f dash of x is defined for all x in the open interval minus 2 comma 2. Okay, for suppose, okay, in the open interval minus 2 comma 2. Okay, so first let us take any point in the open interval. Okay, so first let us, so here I am taking x is equal to 1. Okay, at x is equal to 1, f dash of x 2. Okay, at x is equal to 1, f dash of x is equal to 2. Okay, therefore f dash of x is defined. Okay, similarly let us take at x is equal to 1.5. At x is equal to 1.5, f dash of x is nothing but 2 into 1.5, 3. Here also f dash of x is defined. That means f dash of x is exist for every x in the open interval minus 2 comma 2. F dash of x exists for all x in the open interval minus 2 comma 2. Here if f dash of x is exist for all x in the given open interval, then only we can say that Rolle's theorem is applicable. Okay, if suppose f dash of x does not exist or undefined in the given open interval, then we can say that Rolle's theorem is not applicable. So here Rolle's theorem work only if f dash of x exists for all x in the given open interval. So here Rolle's theorem work only if f dash of x exists for all x in the given open interval. Okay, remember that point students. Okay, so here f dash of x is nothing but 2x. Okay, tell me f dash of c. F dash of c is nothing but 2c. Okay, next take f dash c is equal to 0. F dash c is equal to 0 is nothing but 2c is equal to 0. 2c is equal to 0 is nothing but c is equal to 0. We can see that c is equal to 0 which lies in the open interval minus 2 comma 2. Okay, that means so here we can see that c is equal to 0 which lies between open interval minus 2 comma 2. So we can say that Rolle's theorem is verified. Okay, suppose Suppose we cannot find the value of c which lies in the given open interval, so then we can say that Rolle's theorem is not applicable. So here we can see that c is equal to 0 which lies in the open interval minus 2 comma 2. So we can say that Rolle's theorem is verified. Write down Rolle's theorem is verified. Okay. Okay, student. So here remember very important point. So here f dash of x is defined for every x in the open interval minus 2 comma 2. So Rolle's theorem is applicable. Okay, if suppose f dash of x does not exist in the given open interval, so then we can say that Rolle's theorem is not applicable. Remember that point. Okay. So next I will explain one more problem. Okay. Second one, verify Rolle's theorem for the function f of x is equal to 2x square minus 5x plus 3 on closed interval 1 comma 3. Okay, so here I am taking polynomial function. Okay, so here write down directly, no problem. What is the first condition? F of x is continuous on closed interval 1 comma 3. Next, f of x is differentiable dble on open interval 1 comma 3. Okay, now let us check third condition. Okay, f of 1, tell me, f of 1 is nothing but 2 minus 5 plus 3. Okay, minus 3 plus 3, 0. Next, f of 3, tell me, f of 3 is nothing but 9 into 2, 18 minus 15 plus 3. Okay, 18 minus 15, 3 plus 3, 6. So here we can see that f of 1 not equal to f of 3. Okay, so we can say that Rolle's theorem is not applicable for the given function. Okay, on the interval 1 comma 3. So write down RT means Rolle's theorem is not applicable. Rolle's theorem is not applicable for the given function in the interval 1 comma closed interval 1 comma 3. Next, third problem. Third one, f of x is equal to x power 2 by 3, x power 2 by 3 on closed interval minus 1 comma 1. Okay, so here also I am taking polynomial function. This is polynomial function. Okay, write down directly, no problem. F of x is continuous on closed interval minus 1 comma 1. Second one, f of x is differentiable on open interval minus 1 comma 1. Okay, next, third condition, f of minus 1, tell me, f of minus 1 is nothing but minus 1 whole power 2 by 3. Okay, minus 1 whole power 2 by 3 can be written as minus 1 whole square whole cube. Minus 1 whole power 2 by 3 can be written as minus 1 whole square whole power 1 by 3. Okay, whole power 1 by 3. Okay, minus 1 whole square is nothing but 1. 1 power 1 by 3 is nothing but 1. Next, f of 1, tell me, f of 1, tell me, 1 power 2 by 3, 1. Therefore, f of minus 1 is equal to f of 1. Okay, Therefore, f of x satisfies all these three conditions. So we can say that, okay, Rolle's theorem is applicable. So here, remember that point, students. So next we have to check differentiability. So next we have to check the derivative of the function at x is equal to 0. Okay. Okay, students, first we have to find the derivative of this function. F dash of x, tell me f dash of x. 2 by 3 x power 2 by 3 minus 1 minus 1 by 3. Okay, minus 1 by 3 is nothing but 2 by 3 x power 1 by 3. Okay, f dash of x is nothing but 2 by 3 x power 1 by 3. Students, here you can observe here, student. Okay, at x is equal to 0, what happened? At x is equal to 0, what happened? F dash of x. Okay, so here I am taking x is equal to 0. I am taking the point. I am taking 0 in the open interval minus 1 comma 1. Okay, at x is equal to 0, what happened? Tell me. At x is equal to 0, f dash of x is equal to 2 by 3 into 0 is nothing but 2 by 0 is nothing but infinity. That means undefined. Okay, at x is equal to 0, f dash of x does not exist. Okay, so here I am taking 0 in the open interval minus 1 comma 1. Okay, so next we have to check derivative of the function at x is equal to 0. So here f dash of x is undefined. Okay, so we can say that f of x is not differentiable at x is equal to 0. Okay, that means Rolle's theorem is not applicable. Not applicable. Rolle's theorem is not applicable to the function on the interval minus 1 comma 1, on the open interval minus 1 comma 1. So here f dash of x does not exist at x is equal to 0. So f dash of x undefined at x is equal to 0. So here Rolle's theorem work only if f dash of x exists for all x in the open interval minus 1 comma 1. But here f dash of x does not exist in the open interval minus 1 comma 1. So we can say that Rolle's theorem is not applicable. Okay, if f dash of x exists for all x in the given open interval, then only we can say that Rolle's theorem is applicable. If suppose f dash of x does not exist for all in the given open interval, then we can say that Rolle's theorem is not applicable. Don't confuse. Okay. So now I will give you some problems. Okay, do it students. Write down, verify Rolle's theorem for the following functions. First one, f of x is equal to x minus 1, x minus 2, x minus 3 in closed interval 1 comma 3. Okay, write down direct first condition, second condition, no problem. Next, f of x is equal to x square minus 5x plus 6 in minus 3 comma 8. So here I will give you c value. So here c is equal to 2 plus or minus 1 by root 3. So here c is equal to some pi by 2. Okay, so that is the answer. Third one, f of x is equal to sin x minus sin 2x in the closed interval 0 to pi. Okay, so here this is trigonometric functions. Okay, write down directly f of x is continuous and differentiable. Okay, so here what is c? C is equal to cos inverse of 1 plus or minus under root of 33 by 8. Okay. Fourth one, log of x square plus 2 minus log 3 on closed interval minus 1 comma 1. Okay, so here c is equal to 0. Fifth one, f of x is equal to 1 minus x power 2 by 3 on minus 1 comma 1. So answer is not applicable. Okay. Sixth one, f of x is equal to cos 2 of x minus pi by 4 on closed interval 0 to pi by 2. Answer is, what is c? Pi by 4. c is equal to pi by 4. Do it, students. Very important and very easy.